In this video, we are going to now look at how to calculate the free fall values precisely. And so that means using formulas, and it means using calculators. So let's look at the things we know. We looked up and found out the delta Z, and that delta Z is 434.1 meters. So we know delta Z. But for this, the problem of Blake dropping this thing, we aren't given the velocity, average velocity, and we aren't given the time. We figured out an estimate of it from the average velocity table, but we don't know it. We're not given it. We know the initial velocity was 0, but we don't know the average velocity, nor do we know the velocity on impact. We do know the acceleration, and we know the initial velocity, but we do not know the impact velocity, nor do we know the change in time. So we can see then is if we tried using all the formulas we know, there's two things we don't know, two things we don't know, two things we don't know. So we cannot calculate the answers to these questions just using these formulas. We need a new formula. And that formula is right here. And in the previous video, we saw that the position time is given by a parabola. And this is actually the equation. It is the change in vertical position is equal to 1/2 the acceleration multiplied by the time squared. And as a refresher, that graph we saw for position in time, it looked like this. And we said that that's generally an equation of the form y equals ax squared, where the y-axis is z and the x-axis is t, and there is this acceleration, this capital A. Now what that tells us is this capital A is not the little a. In other words, this 1/2 A equals this big A. So 1/2 little a equals big A. Or the acceleration is equal to twice that letter A, whatever, that capital letter A, whatever it is. But in any case, we can use this equation to find out some values. So first we know the delta Z. We know delta Z, and we know A, we just don't know T. So our first step is to solve this equation. What we want is an expression in the end that says T equals. So starting from left to right, we need to get rid of this 2. And the way we do it is we multiply both sides by 2. So that gives us 2 delta Z equals AT squared. And now that A is a problem. So the way we get rid of the A is to divide both sides by A. And that gives us an expression, T squared is 2 delta Z all over A. Well, we're getting closer, but to get rid of that T squared, we need to take a square root of both sides. So we have the square root of T squared equals the square root of 2 delta Z over A. So we're left with T equals the square root of 2 delta Z all over A. Now, the delta Z is 434.1, and the A is 9.80665. So how do we use our calculators to compute this? So let me show you how. So we go to our calculator here, we'll clear it out, and we want the square root. And there's a square root key, it's the x squared key. But we've got to hit the blue key, second x squared. And it was 2 times delta Z, which is 434.1, divided by 9.80665, which we stored as G. And we hit enter, and lo and behold, we get 9.4091318. 9.4091318 seconds, because it's time. And if we remember, our estimate was it was less than 9.5 when we did the average velocity table. So lastly, we need to use our significant digits. This 9.80665 has 6 digits, and this one had 4, so we can report 4 answers. And so that gives us T equals 9.409 seconds. So that's how long it takes to hit the ground, 9.409 seconds. Now what about now we know that T, and that t is the delta t, starting at 0 and 9.409 seconds. So we now know delta t. So what can we find? We can now find this value of the impact velocity, which occurs there and it occurs here. And so you can still see that with this equation, there's two we don't know, and this one doesn't even have it involved. So we can use this equation to find it. So we have A equals V minus V0 all over delta t. Now V0 was 0, so that gives us A equals V over delta t. So to get that V by itself, we need to multiply both sides by delta t, and that gives us V equals A times delta t, and that acceleration, 9.80665 times 9.4091318 is going to give us that velocity. Now we can go back to our calculator, now that we know that it's that time multiplied by the acceleration. Go back to the calculator, and we can say, well, there's our time. We want to take that answer. We just hit times alpha g. And that gives us 92.27206. 92.20276 meters per second. Let's make sure I remember that correctly. Like 27206. 92.27206. And so lastly, this number had 6 digits, and this number we could only report 4. So again, we can only report 4. And our final answer then is 92.27 meters per second. And if we write that in scientific notation, that is 9.227 times 10 to the 1 meters per second. And so we have our unrounded, rounded, and in scientific notation answers. So this is how we can find the value very, very precisely. And we estimated this value to be about 94. So we were off by a couple, but we were pretty close. This one we estimated to be less than 9.5, and we were right on the money. So that's how we go about calculating the values precisely.